Here's integrated 3. It's CL11-115. Perform the indicated operation of each of the following rational expressions and state any excluded value. So I'm going to exclude values that make a zero denominator. So if I have x equals 0 right here, that would make a zero denominator, so I need to exclude that. And right here, if I factor this out, I would get, again, x. If x is 0, I have a zero denominator. But also here, 2x plus 1, if x is a half, negative a half, I don't want that as a denominator either. Let's check and make sure that's right. Yeah. So from the original problem, I get that x can't be a half and x can't be 0. And then I'm going to get maybe a few more excluded values as I finish the problem. So what I've done here is, instead of writing down the original, I took the second fraction and flipped it upside down so I can multiply. Flip and multiply, that's what, I'm multiplying by the reciprocal. And so now that I'm multiplying, I want to cancel things out if I can. So I need to factor everything that I can factor. And so this thing is called a difference of squares. This can be written as x squared minus 1 squared. So I just identify that as a difference of squares. There's a factoring pattern for difference of squares, and it's something squared minus something squared. It's something plus, it's like the first thing plus the second thing, and the first thing minus the second thing, if that made any sense. You can just follow this pattern. So in this case, A is going to be x, and B is going to be 1. So I'm going to have x plus 1 and x minus 1 divided by x. So that's this first fraction. And then this one, I can factor out the common factor of x, and then I'll get x times 2x plus 1. And then down here, I did a diamond problem, and I see that I was looking for something that multiplies to make 1 and adds to make negative 2, so that came out to be x minus 1 times x minus 1. Then I canceled out my common factors, and then I was left with x plus 1 times 2x plus 1 all over x minus 1. But right here, I get another value that I can't have. If I put x as 1, I would get a 0 denominator. So these are from here, and from the original, I had x half. So these are the excluded values, and this is the simplified problem.